Parametric equations and motion. Example 1, graph the parametric equation. And all what you have to do, you build up a table, you list the values of t as you can see. Then you say, okay, x equal 3 minus t squared. Thus I will start replacing the value of t and find the final answer for x. I will repeat the same process, but this time for y, and I will find each value for y. Then I will combine the values of x and y in one order pair, which is x comma y, as you can see in front of you. After finishing the table, I will go to the xy coordinate. I will plot the final points xy on the graph, and I will connect them. Another example, we have the values of t, we bank a table, we list the values of t. In this situation, we're dealing with angles. We substitute the values of t and x to find the values of x. We do the same process for y, as you can see in front of you. Then we will build up the order pairs, which is x comma y. After that, you will graph the xy coordinate, you will plot the points and connect them. You can freeze the screen to check the table while studying. Okay, now pause your screen and solve the following question, then compare your answers. Okay, now another example about solving by elimination. Again, we figure out that y equal t, thus we can use it in x equal t plus 1 by saying x now will be y plus 1. We arrange the shape and it will be y equal x minus 1, and it's a line. Okay, another example, solving by elimination, but this time if you notice x equal 5 minus 3t, y equal 9 minus 4t. My preference, take x and try to solve it for t. Thus you need t equal. You can replace like 3t equal 5 minus x, as you can see in front of you. Then you get rid of a 3 by dividing over it. And then the value of t, you will use it inside y. Thus y equal 9 minus 40, but this time you will replace t by the value 5 minus x over 3, and you will simplify and you will discover the shape eventually. In this case, it's another line. Okay, last question about elimination. Here we have x equal to t squared minus 1, y equal t. I will replace t by y inside x, and I will solve it for y. I will have x plus 1 equal 2y square. I will divide both sides now by 2, and eventually it's a parabola. Parametrization for a line segment. And to be honest, line segment and line, they are the same for me. Thus, let's start with the following example. Find the parameterization of the curve for a line between the 2 points. My suggestion, first of all, you need to graph and know your starting point. In my case, I already know. Then you have to find the slope. Now the slope shows -3 over 6. The line is decreasing, and my anchor point is -2 and 5. Because it's a line segment, you're advised to use always t between 0 and 1, as you can see. Now, since -2 and 5 is the start point or the anchor point, I will say, okay, I will deal now with the x part inside this point by saying x equal -2 plus at. I will repeat the same thing, y equal 5 plus bt. Now, because the slope is -3 over 6, in my mind, -3, the upper part of any slope is related to y. Thus, the lower part is related to x. Thus, my equation will be x minus x equal -2 plus 6t. The 6 comes from the slope denominator, and y equal 5 minus 3t from the numerator from the slope. Please see the steps in front of you in details. I already did the parameterization part, but you can, if you want, solve for t. Like take x equal -2 plus 6t, solve it for t, go back to y equation, replace it, then you will have the original equation of the line. Okay, freeze your screen and solve this question and compare your answers. Parameterization for a circle. Now we will recall in unit circle x equal cosine theta, y equal sine theta, and theta is ranging between 0 and 360. Okay, example 1. Give a parameterization for a circle with the center 2, 3 and radius 3. Now we will use x equal r cosine t and y equal r sine t. We know r equal 3, thus we are gonna substitute it. Now, since the center is 2, 3, the equation will be changed into x minus 2 equal 3 cosine t, y minus 3 equal 3 sine t. We adjust it into x equal 2 plus 3 cosine t and y equal 3 plus 3 sine t, and of course t ranging between 0 and 360. Another example with different radius and different center. Now from the center I can say immediately x minus 2 equal 2 cosine t, and minus is a plus, you solve it for x, and y minus 4 equal 2 sine t, then you solve it for y. Now finally, parameterization for a line, and it's the same as line segment, only t is different, not between 0 and 1. It can be between 0 and 1, but it can be ranged from -infinity to infinity. I'm gonna solve it using a different approach, using the diff vectors. I will take -2, 3 be a starting point, then I will say, okay, vector v consists of the starting point, or the vector point, which is -2, 3, then plus t times the differences between the 2 points, x2 minus x1, y2 minus y1, and that's it. Then you complete the process like this. You find a different solution, well, the same solution or different solution for the parameterization of a line. That was the lesson of today. Thank you so much.